Hey everyone, and welcome back. We're diving deep into AI today.
Oh, fun.
Specifically, Nvidia's new Blackwell architecture.
Yeah.
We've got a whole bunch of articles here
Okay.
from Nvidia and some industry publications. We're going to unpack it all.
Right.
Starting with Foxconn's plan to build Taiwan's fastest supercomputer.
Wow.
It's going to be powered by Blackwell.
I see.
And then we'll look at some performance benchmarks.
Got it.
And finally, we'll wrap up with a design challenge that Nvidia had to overcome.
Sounds good.
So first up, this Foxconn supercomputer,
Okay.
Foxconn, as you know,
Yeah.
is the world's largest electronics manufacturer.
Right.
And they're building Taiwan's fastest AI supercomputer using Nvidia's Blackwell architecture.
Wow. And this is a big one.
Huge.
The Hanhai Kaohsiung Supercomputing Center.
Right.
It's expected to reach over 90 exaflops of AI performance.
90 exaflops.
90 exaflops, yeah.
That's just...
To put that in perspective,
Yeah, please.
1 exaflop can perform a billion calculations per second.
A billion.
90 exaflops. It's unimaginable computing power.
It really is.
Yeah.
The articles mention it'll use the GB200 NVL72 platform,
Right.
with 64 racks and 4,608 tensor core GPUs.
Wow.
But what's even more interesting is what Foxconn wants to do with it all.
Oh. Well,
So they have this 3-platform strategy
well,
focusing on smart manufacturing, smart cities, and electric vehicles.
interesting.
This supercomputer will drive all of those initiatives.
So it's like the engine behind it all.
Exactly.
Yeah, imagine the possibilities for smart manufacturing.
Oh, yeah.
This supercomputer could run these really detailed simulations
Right.
to optimize production lines
Yeah.
and potentially even predict problems before they happen.
Preventative, yeah.
Yeah.
And for smart cities,
Yeah.
analyzing tons of data,
Oh, I see.
like traffic patterns or energy consumption, even environmental conditions,
Wow.
to help improve efficiency and sustainability.
It's like a giant brain managing an entire city.
It is, yeah.
And electric vehicles, too. Developing and testing autonomous driving algorithms.
Right, because they'll need that computing power.
Exactly. It could completely change how we think about transportation.
It really could.
Yeah.
And it's all happening pretty soon.
Okay.
The first phase is set to launch by mid-2025.
Oh.
Full system deployment in 2026.
It's not that far away.
No, it's not.
It'll be fascinating to see what Foxconn does with it.
Right.
This really positions Taiwan as a major player in AI.
Absolutely.
Yeah.
I really like this quote from Foxconn Vice President James Wu.
Okay.
He said, "Powered by Nvidia's Blackwell platform, Foxconn's new AI supercomputer is one of the most powerful in the world, representing a significant leap forward in AI computing and efficiency."
It really highlights the significance of this project.
For Foxconn, but also for AI as a field.
Exactly.
Now let's talk about what makes this Blackwell architecture so groundbreaking.
Okay.
One article goes deep into its performance in these MLPerf inference v4.1 benchmarks.
MLPerf benchmarks.
Yeah, can you explain what those are?
Sure. So they're like standardized tests for AI hardware.
Okay.
They measure how quickly and efficiently a system can perform tasks.
Got it.
Things like image recognition
Yeah.
or natural language processing.
So it allows for fair comparisons across different platforms.
Exactly. Apples to apples.
And Blackwell aced these benchmarks, right?
It did.
The article said up to 4 times more performance than the previous generation.
Wow, that's significant.
Yeah, the H100 GPU.
Yeah.
Especially on this Llama 270B LLM workload.
Right. We need to talk about LLMs.
Okay, LLM.
Large language models.
What are those exactly?
These are the AI systems that understand and generate human-like text.
Like those chatbots.
Exactly. And Llama
Okay.
270B is a specific LLM.
I see.
Very complex, very demanding to run.
So Blackwell's really good at dealing with that.
It is.
But what does that mean for, like, the average person?
Well, it means AI applications could become way more sophisticated
Okay.
and way more responsive.
Okay.
Think of AI-powered tools on your phone,
Oh.
working seamlessly and instantly.
Okay.
Voice assistants that can actually hold a conversation.
Wow.
Real-time language translation, much more accurate.
That would be amazing.
Personalized recommendations that really understand your preferences.
Oh, that's interesting.
So basically, AI is faster, smarter, and more helpful.
In everyday life.
Exactly.
I like the sound of that.
Yeah.
The article mentioned Blackwell's second-generation transformer engine
Right.
and FP4 tensor cores
Yes.
as reasons for this performance jump. What are those?
Think of them as specialized hardware,
Okay.
designed for the calculations that large language models need.
Right.
The transformer engine is good at processing sequential data, like words in a sentence.
Mm-hmm.
And the FP4 tensor cores offer a new level of precision and efficiency.
So it's this combination that
Yeah.
allows Blackwell to handle those LLMs.
Exactly.
And as these LLMs get bigger and more complex,
Yeah,
the need for multi-GPU computing becomes even more important.
absolutely. Even with these powerful GPUs, sometimes you need multiple GPUs to handle the scale
Yeah.
working together.
That's where NVIDIA's NVLink and NVSwitch technologies come in.
Exactly.
Can you explain those?
Sure. So imagine NVLink is like a super fast highway
Okay.
connecting multiple GPUs,
Got it.
allowing them to share data and work as one.
Interesting.
And NVSwitch is like the traffic controller,
Okay.
making sure data flows smoothly between the GPUs.
So creating a super brain out of many individual brains.
Exactly.
And the Blackwell platform is pushing this further
It is.
with these 72 GPU NVLink domains.
Right, essentially connecting even more GPUs together.
Wow, creating massive processing power.
Yeah,
This makes a lot of sense for Foxconn's supercomputer.
it does.
That level of performance and scalability
Right.
is what they'll need for their 3 platforms.
Exactly.
Okay, so we've got supercomputers, these new GPUs.
Yeah.
But the article also mentioned the Nvidia H200 GPU.
Correct.
Performing well on the Mixtral 8x7B MOE LLM benchmark.
MOE.
Can you explain some of those terms? Sure.
Starting with MOE models.
MOE stands for Mixture of Experts.
Okay.
It's a new approach to building AI models.
All right.
So instead of one giant neural network,
Yeah.
you have a collection of experts,
Uh-huh.
each trained on a specific task or domain.
Like specialists.
Exactly. So instead of being a jack of all trades,
Right.
the model calls on the best expert for the job.
I see. That's really cool.
And this is more efficient
Okay.
because you only activate the experts you need.
Right.
It's also more versatile
Okay.
because you can add new experts as needed.
Without retraining the whole model.
Exactly.
Wow, that's fascinating.
Yeah.
And the Mixful 8x7B,
Yes,
that refers to a specific MOE model.
it does. It's
That-
gaining popularity
I see.
because of its performance and flexibility.
Okay.
The fact that the H200 GPU did so well on this benchmark
Yeah.
shows that NVIDIA is focused on supporting these AI models.
That's great to see.
Yeah.
Now, there's also this design flaw.
Oh, right. That NVIDIA faced during Blackwell's development.
Yes, it shows that even the most advanced companies
Yeah.
can run into hurdles.
Mm-hmm.
This flaw impacted production.
Right.
It caused shipment delays to big clients.
Like who?
Meta, Google, Microsoft.
Those are big names.
Yeah, it was a big deal.
I remember their stock dropped 8% when the news broke.
Right, but the flaw was related to manufacturing yield,
Okay.
not the actual design.
Got it.
Nvidia was very open about the situation.
That's good.
Yeah, Jensen Huang, the CEO,
Oh.
addressed it publicly
I see.
and explained how they were fixing it.
Which is what you want to see.
Absolutely. Transparency and accountability.
So how did they actually fix it?
They worked with TSMC,
Their manufacturing partner?
yes, and modified the GPU mask,
Oh, okay.
which is like a stencil used in chip making.
Got it.
By tweaking the mask, they improved the yield.
So they could produce more working chips.
Exactly.
That sounds complex.
It is.
Are they back on track now?
They are, the articles say, Blackwell chips are in full-scale production.
Good.
Yeah. And Nvidia stock has rebounded.
So investors are confident.
Yeah.
That's good to hear.
It really shows their expertise and determination.
Right. Finding solutions.
It speaks volumes about their engineering,
Yeah.
that they identified the issue and fixed it so quickly.
Absolutely.
It shows their commitment to the product.
Definitely.
Yeah.
Okay, before we move on,
Yeah.
I wanted to touch on NVIDIA's involvement with the Open Compute Project,
OCP.
the OCP Global Summit. Yes.
Tell me more.
Can you tell us about that?
Sure. So the Open Compute Project is all about open standards
Okay.
and collaboration in data center technology.
Got it.
Companies working together to build better data centers.
And why is NVIDIA's involvement significant?
It shows they're committed to being part of a larger ecosystem,
Okay.
not just focused on their own technologies.
I see.
They're working to advance the industry as a whole.
That's great.
Yeah.
And Ian Buck, their VP of Hyperscale and HPC,
He gave a keynote address
he did.
focusing on the challenges
Yeah.
of designing data centers for AI.
That's a crucial topic.
It is.
As AI workloads become more demanding,
Right.
we need to rethink how we design these data centers.
Yeah, it sounds like we're on the cusp of major changes.
Absolutely. A new era of data centers designed for AI.
We've covered a lot already.
We have.
Foxconn's supercomputer, Blackwell's performance.
Yeah.
Even that design challenge,
Uh-huh.
I need a minute to process it all.
Me too.
We'll pick up right where we left off in part 2, so stay tuned.
Sounds good. Welcome back. Everyone, you know it's easy to get lost in the details.
Oh, yeah.
I think we should step back and think big picture for a sec.
I agree. What are the implications of all this? We've talked about all this processing power,
Yeah.
but how does that actually change things in the real world?
Well, let's think about scientific research.
Okay.
With these powerful AI systems using Blackwell,
Yeah.
researchers can analyze huge data sets,
Right.
run complex simulations
And maybe even speed up discoveries.
in like medicine or climate change.
Exactly.
Yeah.
Like giving scientists a superpowered tool.
To help them solve tough problems.
Yeah, instead of waiting years for results,
Right.
they could make breakthroughs much faster.
That makes sense. And it's not just science, right?
No, not at all. Think about finance.
Okay.
AI could analyze market trends,
Oh, interesting.
make better investment decisions.
And transportation, too.
Of course, AI could optimize logistics,
Right.
improve traffic flow in cities.
So AI is going to change how we live and work.
It really has that potential. But there are risks, too.
Right. We have to be careful.
Any powerful technology has risks.
True. As we develop AI,
Yeah,
we need to make sure it's used responsibly.
ethically.
How do we do that?
I think open discussions are key,
Okay.
and transparency. Nvidia is showing commitment to that.
By being part of the Open Compute Project.
Exactly. It's a step in the right direction.
The more we can work together on this, the better.
Absolutely.
Mm-hmm.
And it's not just up to big companies,
Or governments.
right? Everyone has a role to play here.
So what can we do as individuals
Well, we need to stay informed.
about these AI advancements?
Yes. Understand the benefits and the risks.
Right.
We can't just let it
They
happen.
have to be active participants.
Exactly.
It's easy to feel overwhelmed by all this.
It is. It's complex and changing so fast.
How can we actually make a difference?
Knowledge is power.
I like that.
The more we understand AI,
Yeah.
the better decisions we can make.
So what can we do practically?
Stay informed.
Okay.
Read articles, listen to podcasts.
Like this one.
Exactly. Ask questions.
Got it.
Understand different viewpoints.
The more we understand, the better.
Right. We can be part of the conversation.
What else can we do?
Support organizations working on ethical AI.
Oh, that's a good idea.
There are a lot of groups out there.
Doing good work.
Researching the risks, developing guidelines,
Oh, yeah.
advocating for responsible development.
So we can help ensure AI is used ethically.
Exactly.
What else? This is all really helpful.
So talk about it.
Talk about AI.
Yeah. With friends, family, colleagues.
Oh, I see.
The more we talk about it,
Yeah.
the more we can make sure it reflects our values.
It's not just a tech issue then.
No,
Yeah.
it's a societal issue.
I love that. So stay informed.
Yes.
Support those ethical AI initiatives
Uh-huh.
and talk about them.
Exactly. It's a collective effort.
We all have a part to play.
You know, speaking of responsibility,
Yeah.
remember that design flaw with Blackwell?
Oh,
I
yeah.
thought Nvidia did a great job with that.
I agree. They took responsibility
Yeah.
and were transparent.
In a world where companies hide things,
Right.
Nvidia's approach was really refreshing.
I think so too. They were upfront about it
They were.
Huh?
And explained what went wrong.
and how they were fixing it.
Yes. Transparency builds trust.
It does, especially in a field like AI.
It shows they care about their customers.
Right.
They're committed to a high-quality product.
Even with the challenges.
It sets a good example for other companies,
So it's okay to admit mistakes.
as long as you fix them.
It builds credibility.
Absolutely. It strengthens relationships.
So to sum up this part,
Yeah.
we've talked about AI's potential impact
Mm-hmm.
and the need for responsible development
Right.
and the importance of transparency.
It's all connected.
What's next?
In part 3, we'll have some final thoughts
Okay.
and leave you with something to think about.
Stick around for part 3, everyone.
All right, welcome back for the final part of our deep dive.
Yeah, it's been a fascinating one.
We've covered so much: supercomputers, benchmarks,
Design challenges, ethics.
but a lot to take in.
It is, but it's all connected.
So for anyone who just joined us, let's recap.
Good idea.
We started with Foxconn's plan for Taiwan's fastest supercomputer.
Powered by Blackwell, of course.
Right, NVIDIA's Blackwell architecture.
It'll be operational in phases starting mid-2025.
And a total game changer for Foxconn's 3-platform strategy. Smart manufacturing, smart cities, electric vehicles.
That level of computing power could revolutionize those industries.
Absolutely.
Then we talked about what makes Blackwell itself so special.
Those ML-perf inference benchmarks.
Right. Blackwell achieved 4 times the performance of the previous generation.
Especially with those large language models.
LLMs.
We also dug into the technical stuff.
2nd generation transformer engine, FP4 tensor cores.
All designed to speed up those complex calculations.
And then there's those mixture of experts models. Using those specialized AI experts.
Like a team of specialists on call.
It's really incredible.
It is. It shows how AI is evolving.
We also talked about that design challenge Nvidia had,
It happens, even to the best.
but I was impressed with how they handled it.
They were open, transparent.
Explained the flaw, explained the fix.
They took responsibility and acted quickly.
It shows real commitment to their customers.
And to the quality of their products.
Definitely. And they worked with TSMC to modify the GPU mask.
Got those chips back into full production.
It shows their resilience, their expertise.
And lastly, we talked about the Open Compute project.
OCP.
Nvidia is really active there,
It shows their dedication to open standards.
working together to shape the future of data centers.
It's encouraging to see that kind of collaboration.
Absolutely.
So after all that, where does it leave us?
That's the question, isn't it?
What are the key takeaways? What does it all mean?
I think we're at the start of something huge.
A new era with AI everywhere?
It's exciting, but also a little scary.
Right. This power, this potential,
We have to be careful, use it ethically.
it's not just about technology anymore.
That's about society.
We all have to be a part of this.
So as you continue exploring AI,
Yeah.
think about the impact it will have on your life.
On your work, your community.
How will it shape the world around you?
What are the benefits, the risks?
And most importantly, how can you ensure AI is used for good?
Those are the questions to ask.
Stay curious, keep exploring.
That's it for our deep dive into Nvidia, Blackwell, and the future of AI.
Thanks for joining us.
Until next time, keep learning and keep questioning.